Alright, this lesson we're looking at time series data. So time series data is still bivariate data, so we're looking at two different variables. However, one of the variable, the explanatory variable, is going to be time, so a special type of bivariate data. And it's a scatter plot that we use to show time series. However, they will be connected, so they're going to be joined. And then in time series data, we'll have trends, and that's what we're focusing on today, mainly identifying different trends in time series data. So as you can see, these are some examples. In the explanatory variable, we have time. It could be hours, minutes, day, year, monthly, quarterly, so any sort of time, and then against all different things on the response variable. So talking about trends in time series, here are some main features of time series that we are trying to look for, and here are 6 main features that we're looking at today, and our goal is to be able to identify these when we look at a time series data. So we'll look at all of these 6 sort of in detail, starting with the first one on the list, which is trend. So when we talk about trend, we're generally just talking about if it's going up, so upward, or going down, downward. So it's going to be fairly obvious, but one way to make sure that it is going up or down is to draw a line that sort of goes through the middle of your time series, and it sort of follows, your time series follows along that line. Then you know it's you know the trend of the time series. And the next thing we're looking at is cycles. So cycles are, as it's in the name, some movements in the time series that's happening over and over. So the way to identify cycles in a time series data is to look for patterns of peaks and troughs, and so those are highs and lows, and then calculating what time between each one. So for example, we're looking at this one here. This one's pretty obvious. All the sort of highs are here, the lows are here, and was looking at the length between one from the other, and this one's roughly 10 years. As you can see in the data, 1900 to 1910, and in the data, as you can see, it's being repeated over and over again, so that's clearly a cycle. Next thing that we're looking at is seasonal variation. This is very similar to cycles. So you can see in this example, you can see there's like a cycle going on here. The main difference between cycles and seasonal variation or seasonality is the period of the cycle. So if it's 1 year or less, so that's including every year, every quarter, every month, every week, we call that seasonality or seasonal variation. Whereas for cycles, I didn't really point it out before, it needs to be greater than 1 year. So over here, because this was for every 10 years, this we call it as a cycle. This one over here is looking at sort of every season. So there's 4, so every quarter. So here there's 4 data for just 1998, and then there's another 4 obviously for 1999, and so on. So we're looking for less than a year. So any sort of pattern here, we call that seasonality or seasonal variation. And for this one, as you can see, is roughly about a year. So you can see the low here and here, and the time between them is June of 98 to June of 99, so you can see that's 1 year. So if you were to ever comment on a time series data, here is a sort of a template that you can follow. So make sure to fill these out so you have this in your bound reference. And here are a couple of more situations where it's likely to have seasonal variation. One of them is in the name, it's by the seasons. So like in summer, every summer the ice cream sales will go up because summer's hotter, people buy more ice cream. Same with swimming pools, gas bills high in winter, so that sort of thing. The other thing is not to do with seasons, but sort of like holidays or events that's celebrated by a lot of people, so such as Christmas. You'll see like things will be more expensive around Christmas, or people buy more chocolate around Easter. That sort of thing will obviously affect, or it will increase the chance of having seasonal variation in the time series data. And the next thing we're looking at in our time series data is structural change. We say there's a structural change when there's a sudden change in the data, but the pattern of the data hasn't actually changed. So for example, this data is sort of steady, and then there's a massive drop, and then it sort of becomes steady again. So this bit in the middle, we identify this as the structural change, where the trend of the data is actually very similar, but there has just been like a massive change. It could be a massive drop, could be a massive increase. So that's a structural change. But not to be confused with outliers, where for the rest of the time series data, there's a very clear pattern, but then there's just one that is obviously away from the rest of the data. And this is different to a structural change, where the structural change happens here and then the pattern sort of doesn't change after that. Whereas for outliers, it's the entire thing is just one pattern, but then there's a drop in one spot. Whereas again, this one pattern here, drop, and then the pattern continues. So if this was an outlier situation, this whole thing will be up here, having the same pattern instead of this, and just having that one drop. But obviously, that's different to the outlier. And obviously outliers can happen because there'll be random factors that'll affect the data. It could be that there's a war that broke out, could be a bunch of different things, but they're all different to all the other things that we talked about, like seasons. All of that would show a different type of variation in your data than an outlier, where it's more like a one-off thing. So all of these that you just need to know how to identify them. So we've covered all 6 of these. And so an example question like this, you might see in the exams. So it might simply ask you to list all the features that you see in this time series plot. And for this one, it's very clearly there's no outliers. It's sort of going up overall. It does have seasons, like this trend, and because the time period that this trend is happening is just about 1 year, this will be identified as seasonal variation rather than a cycle. So that's all you need to say. So there's an upward or increasing trend, and there's a seasonal variation in the data. The last thing I want to bring your attention to is constructing time plot series using your CAS calculator. So if you're given data like this, where these are very easy to type into your CAS, they're just numbers. However, your EV, your time, will be given something like this. Now, best way to put these in is to give them what we call a time code. So representing, like, the first thing that you're given is 1, this is 2, so on and so on. So putting them as 1, 2, 3, 4, 5, like numbered time, rather than putting it, obviously you can't really put 8th of January into your CAS. And then you know how to put this data into a scatter plot, and only extra thing you have to do is just pressing Control menu and then getting this little menu pop up and selecting connect data points, and it will give you a time series plot.